Hello, hi, namaste, and welcome to Webinar Nepal Series 33 session on the big quantum theory. I'm Salisha Chitri, a moderator of today's series, being organized by Webinar Nepal and supported by Blink Ventures, Microsoft Inc., and ICT Award. So, talking about Webinar Nepal is a platform with aim to create a strong social community to radiate and to deliver the information about technology and to guide the people how to deliver and how to use the tools and technologies to increase the work productivity. And our target attendees are program developers, software engineers, students, engineers, whosoever would like to scale up themselves in the technological domain. So today we are having two of the finest speakers who are having more than 25 years of experience in IT and business industry. And they are none of the other. They are Miss Viviane Ribeiro and Mr. Andre Melancia. Talking about Miss Viviane Ribeiro, she is the CEO of BI de Brasil MasterDataLab, CSA, and results. And our next speaker is Mr. Andre Melancia, who is a developer, a DABA, Microsoft certified trainer, as well as owner and the principal consultant at Lunar Cat Private. And it's a sheer pleasure for Webinar Nepal team to having both of the speakers on our panel. And without wasting more of your time, I would like to welcome both of them on floor. And over to you, Viviane. Thank you so much for accepting our invitation and being here with us. Thank you so much, and over to you.
Thank you, Salisha. Thank you so much for inviting me for this session. It's a pleasure to be here with you all, sharing some knowledge and some best practices. So welcome everyone to this session. My name is Viviane Ribeiro, and you can follow me on social networks. And if you have any questions after this session, feel free to send me an email. Basically, in the next few minutes, I want to share with you some best practices for architecture and real-time data. Everyone is already able to see the screen?
Yes, ma'am.
Okay, I am seeing someone saying yes, you can go. So let's keep moving on. Basically, I am quite passionate about data, and we know that Microsoft and the big players are investing a lot in some technical and some solutions for us. And talking about the Microsoft side, we have a lot of solutions and services that are able to provide us some extra insights about our data. And the main question that usually we have and most people has is, which one of these solutions should I be using for my environment? And so during this session, it's about this that we are going to talk about. So basically, we have Azure SQL database, Azure Cosmos DB for no relation or no SQL data. We have Azure Synapse Analytics. I don't know if you already heard about it, so let me know during the session if you are using any of these kind of solutions. We have Azure Data Lake and Azure Databricks to compose the solution and all the architecture. Working with real-time data is really impactful because it brings a lot of innovation and it allows us to change the way that business and companies connect with their customers and partners. So it opens a lot of possibilities working with real-time data. But at the same time, we have some main challenges to understand about our data and how we are going to process all this. So our big challenge that we have is we need to ingest, process, and store messages in real time, and especially at high volumes without losing any kind of data. When we are talking about real time, we need to act on data quickly. So I need to generate alerts in real time or presenting them in a dashboard, in a Power BI front-end tool at that time that the data is coming through. But one main thing is, for example, if I am checking about some transactions or about some bank transactions, I need to identify if that transactions are a sample, it will be it's a fraud or not. And if I detect that it's a fraud, I need at right there at right that time to present these or to generate any kind of alerts or actions on it. I need to map all the data producers and the data consumers that I have. So I am collecting this data from an application, or I am getting this data in real time from some kind of device. Because depending the way that I am producing this data, I can choose the services I will be using for it. Simplicity, scalability, and reliability. So depending on the solution and the services that you are going to choose, you have more simplest way to implement it, or you have some additional efforts to manage it. So how do we prepare to scale for data rates and prevent any kind of data loss with these solutions? And the last but not less important than all the others one, it's about security. So we need to encrypt the data. We need to ensure that just the right and authenticate clients will have access to this information. And how we do all this, and what are the kind of architecture that I should be using to process real-time data. So basically here I have, imagine that you have all your data source, right? That one, the application or the device that is just, producing the data, it's our source. And we need to have a way to ingest this data. So we need to have a service like Event Hub or IoT Hub or Kafka to receive all this message, the million of messages that are coming per second. And in the next step, I need to have a stream processing tool. This stream processing tool will be collecting all the data from the Event Hub or from the IoT Hub. And I will be saying inside of the stream processing tool that we have several tools. I am going to share some with you. I need to define which kind of data is really important. So I am going to filter and group the data that I need. And I need to choose what is the what's the output and for which kind of solution I should store this data in. So for example, if I just identify that it's a kind of fraud transaction, I can say get this small amount of data and put in the Power BI reporting tool. So I can generate alerts right away. But I can get this data or other kind of data and say at the same time that you are plotting this data in Power BI, I can send this data to a data warehouse or a Synapse analytics tool, for example. So I can store the data for batching process. And the stream processing tool, it will be the tool that it's going to help me to define and to filter and grouping this data and define which one and for which kind of storage I should be using to send this data. And another way that I have here, it's about having these data sources, and I have some kind of data storage like Blob or Azure Data Lake, and I will have the ingestion from these sources. But we have some message ingestion solutions that I just mentioned about Event Hubs, Kafka, and IoT Hub. But each one of the solutions and basically, what are the difference between these main solutions? All of them, they are able to process millions of messages per second. Basically, Azure Event Hub is a PaaS, so platform as a service, and with very few clicks and configuration, I can enable it to start operating on my business, my company. Kafka is an open source message queuing and stream solution. But I need to start Kafka, I need to have a cluster, I need to have a more managed environment, and so I have some managing extra efforts to implement it because I need to have a cluster, I need to manage this cluster, I need to set all the configurations. But in the other way, Kafka is more customizable than Event Hubs. And Azure IoT Hub, basically, it provides you a bidirectional communication between internet-connected devices and some message queue that can handle millions of simultaneously connected devices. Okay, Vivi, so I have all these three main solutions to process the message in real time and receive all this data. Here it's a way to compare the features that I have on each one. And basically we have the notes that we have different support protocols that this can be a requirement for your environment and can define the kind of source and solution you should use. But basically there are three main questions that you should do to yourself when you are choosing the tool that you want to use. So if you need two-way communication between your IoT device and Azure, the option more available for you is IoT Hub. Basically, if you are just starting the project and you are collecting data from IoT device, you should choose IoT Hub. Do you need to manage access for individual devices and be able to revoke access to a specific device? So IoT Hub. When you are defining between Event Hub or Kafka, at the end of the day, you need to ask to yourself, what degree of control do I need? So as I mentioned to you, it's much easier starting and working with event hubs, and it's a very powerful service. But if you need a more customizable environment, one option it would be using Kafka. So let's see this in a practical way. So imagine that I just have here an application that I am collecting data in real time related to the Twitter. So imagine that this application is connected on Twitter and it's collecting some special keywords. For example, here I am collecting data from Xbox, from Microsoft, from Skype, data science. And in real time, I am getting all this data, doing some kind of sentiment analysis and sending it to Power BI. But what exactly I have on the backend? Of course, I could navigate here and I could click on the live tile and check more information about the dashboard. But here, the main point, it's not the Power BI tool. Of course, that it's important too, but it's to show you the backend, what we are going to use in the backend. And so for this, I have here a couple of demos. Let me just small here. So for example, here I have the Power BI with all the dashboards, but I can have some ways to collect this data. One of it is I have Event Hub service started in the backend. As I mentioned to you guys, we need to have Event Hub and the stream analytics. And how it would work this? Event Hub is quite simple. If you go there on portal, on Azure portal, you can click to create the service. You see that there are very few options to configure it and it will be ready to go. As soon as I have the event service, and note you that I have here some dashboards and some way to see the message that are coming through the service, the throughput. Note that I have two namespaces because I have two ways to collect the data. One is coming from an application and another is coming from Azure Databricks. So imagine that you have one option, it's the application, and my application is pointing to my Twitter. Actually, it's this one that my application is pointing on. So I am pointing to this Event Hub and collecting the data. And the other one that I just have, let me go back here. And the other one that I have, it's this one, the Twitter Databricks. Twitter Databricks, it's the second demo. So just imagine that I have here cluster on Databricks and I have some notepads. This is a script that I have, it's a notepad that I have here to process and to connect. Here, note that I am connected to Twitter Databricks Event Hub. So for my service, I have some keys that I am passing the name, and I am here importing some libraries from Twitter. So in this case, I am passing the keys to be able to access it, and I can just connect and send the comments on this notebook to send all the data and collect this in real time. One important thing here is that I am setting which one of the keywords I should be looking to get this data. So in this sample, I am just getting all the information. It's being treated by COVID-19. And so I am processing these in real-time data. And I could have another notebook, just open here to you guys. It's just related to read the message that I have in Event Hub. So basically here, I am connected to the Series, and this first script, I am just connecting to the Series and reading the data. But the results are in a binary format, and it's not a good format to read the message. I cannot understand a thing from here. So I have some libraries and some ways to format the data that's coming. So we have the body field inside of the data that's coming out, and I can just format this body field to bring the data in a way that it's readable, right? So for example, here I can check the timestamp, the time, and the information that I have. But I want to add more intelligence on this thing. And so in addition to just collecting data in real time, I want to put some sentiment analysis on it. So inside of my script, I can just connect to cognitive sources, and I can use some classes and strings here. I can use some sentiment analysis, and I can treat all these and to have it on the end, the text, the body that I have with the message, but I can have the sentiment analysis together here that basically I can have some score from 0 to 1, where it's more closest to 0, it's more negative sentiment, it's more close to 1, it's more positive sentiment. This is one path, one way to structure this, but another way, and the demo that I started showing you, it is showing this data getting out and being plotted in Power BI tool. And to achieve this, I need to have the Event Hub that I am using, and I need to have some Stream Analytics tool. In this case, I just started Stream Analytics Series that I have here. And inside of the Stream Analytics Series, I have a query. This query serves to basically aggregate and filter the data. And for whom know about Transact SQL, it's quite simple way to write queries. And here it's very similar. I have select statement, I have from, group by, so I am grouping all the information I need. And I am mentioning here for where I want to send this data. So in this case, I am sending all the data to a Power BI report. And note that I have more than one select statement. I have more than one query. So I have a second query here, and I can say that it's sending to the Power BI, but to another data set. So I can have several queries, and each one is sending to a different data set in Power BI to be consumed. That's quite cool. And basically here I have the input, and my input for this is it's coming the data all from Event Hub, and the output I am sending to Power BI. And of course, if I come to the Power BI here, and this report that it's configured and set to receive real-time data, I can see all related content. And here I will see the data sets that I am receiving from the Stream Analytics. This is a little bit from the backend side, and just going back to our presentation. So to process real-time data, the best architecture we should be using is basically this. We have some kind of way of event production, and we have applications and IoT device that can be sending all this data. We will have some event queuing and stream ingestion, that it is event hubs, IoT hubs, or I can receive data from blob storage, for example. And we have a stream analytics tool that will be receiving all the data from these different event queuing and service stream ingestion. And we can send to some kind of storage or presentation, or take some actions from the data that we just defined. And here on the stream analytics space, we have some machine learning, some intelligence to it. Exploring some kind of designs and architectures with you. Basically here we have the sources, and note we have Kafka processing all the data coming from sensors and from clickstream and events. We have Azure Data Factory. Basically, Azure Data Factory is a solution to do the extract, transformation, and load the data, but it's more focused to do some batch processing. So imagine if you want to process data in real time, you are going to use some Azure Kafka here on HD Insight, or you are going to use Event Hub or IoT Hub. Azure Data Factory, you are going to use to do some batch processing. So if I want to load data from yesterday or the data from 1 hour ago, I am going to use Azure Data Factory. And I can send this data to Azure Blob Storage or to Azure Databricks. On Azure Databricks, I can prepare and train all the data and all the machine learning models that I can have inside of the data. And I can send this data to Azure SQL Data Warehouse, nowadays Azure Synapse. And I can have Power BI pointing to my Synapse or directly to an analysis service. Another way is I can have some real-time apps pointing to Azure Cosmos DB, and Azure Cosmos DB getting the data from the Databricks. And more one scenario here. Basically, we have here all our source, and here again we have Kafka, we have Data Factory. It's a different way to see the picture, a more updated picture, I would say. But it's basically the same of the other one. Here, Synapse shows up to analysis service to Power BI, and we have Cosmos. In addition, talking about the streaming event ingestion, we can ingress up to 720 gigabytes per hour of raw events. And this is the tool that I was just showing to you about it, that we can use some Transact SQL language to process and to filter and to group by all the data that we are receiving from events hubs or IoT Hub. Related to streaming solutions, I just showed about Azure Stream Analytics, but we have plenty of tools to streaming. So basically, I have this link here. You can get this link and go to this blog post where I am comparing all the solutions that we have and all the difference. Which one of the solutions, how are you going to choose which of the streaming solutions you want or is the more appropriate for your business? Basically, you need to check about programmability. There are some solutions that support Scala, others Python, Java, R. So you need to understand which language you want to work on. Another thing that's the main difference is about the pricing model. Some of the solutions, they cost by streaming units, another per cluster hour. So it's important for you to understand the way that you want to and how much the budget that you have to invest on it. And the integration, so we have different kinds of inputs and syncs and scalability for each one of the solutions. So get this link after the session or during the week, just take a look on it and you see all these spreadsheet comparing all the different kind of solutions. What is the supportability and the general capabilities of each one of them, okay? What else? We have here the data warehousing way. This is another picture. It is showing us about all the sources again and showing the data factory in some different ways that you have to load the data. As I mentioned to you, we have the possibility to have some application that's just connecting to the service and loading the data. We have the data factory tool that it's a kind of ETL tool to help us to transform and load all the data. We have this Azure import export service and Azure data box for who has a lot of amount of data and needs some disks or services to help to load this data to Azure. In the ingest store, we have the data lake and Azure Blob Storage as options to use. And for data processing, we have Azure Databricks. I show it to you during this demo session. And we have for serving storage, we have Azure Synapse, Cosmos DB, analysis services, and we can plot on dashboards and applications. And for operational data, we have Cosmos DB and SQL DB. It's important to understand all the solutions and how they get connected to each other, so you can have a better idea to how to implement on your environment. There are some architectures that we are using with Azure Synapse Analytics and bypassing Azure Databricks. It works too, okay, for some scenarios. Here, almost the same, a little bit more simplest way to see. I have Azure Data Factory. For this case specifically, we are not using real-time data. Note that we don't have any messaging queue service here. So we are just getting all this data using Azure Data Factory. We can send it to an Azure Data Lake storage that can be connected on Azure Synapse Analytics and using Azure Databricks to process and prep and train all the data. So basically, Azure enables us to have insights at cloud scale, and the services that we have for each one of the phases are basically here that I just mentioned to you on the other slides. We have Azure Data Factory for the ingestion process. We have Data Lake Storage for storage. We have Blob Storage too. To prepare the data, we have Azure Databricks and Azure Synapse Analytics. Here in the picture, Azure Synapse Analytics is positioned more as serving, but we have some cases that we are using Synapse between these two layers. And reporting Power BI tool in the front-end side to plot and to visualize all the data. Here, we don't have anything too new that I already showed you. It's just a different way to see Cosmos DB here connected to the apps, and here Synapse Analytics. It's quite the same. And basically, we have all this architecture and all this solution to help you to accelerate the business, to deliver results quickly, and with all these tools and services, you can deliver capabilities that go beyond of data analytics and with business intelligence, bringing some business insight, and you can connect all these, putting together with some machine learning processing. As an additional architecture, to have some additional reference here. Basically, this image shows, let me see what else we have a little bit different from what we already saw. So basically here, we keep having all the data that we are collecting from device, sensor, get. Here, it's mentioned event hub, but as I already mentioned in the session for you, if you have data coming from IoT device, it's important to have IoT hub too. And for all that data in more structured way, we have data factory, data lake we already talked about. We have stream analytics to define for where should I be sending the data that I am collecting. And here we have the cognitive services, Azure Machine Learning applied to Databricks. Okay, and we can have Azure Cosmos DB and Power BI to send the data. Azure Cosmos DB more connect to the application side, and Power BI to deliver all the insights and analytics to the business user. Note that here we have Azure Synapse Analytics, but we don't have Azure analysis services because we have the Power BI Premium capabilities. Okay, so it's a different way to have an architecture too. So not putting the Azure Analysis Services, but having Power BI Premium. And talking about Lambda architecture, basically Lambda architecture is the base for all these that we are talking about. It shows us that we every time that we have some new data.
Can I interrupt?
Yes.
Yeah, so please be conducted till 5 minutes. So we are the time limit.
Okay, how many? How long?
So 5 minutes. 5 minutes, ma'am.
5 minutes? Oh, okay, it's enough for me to finish. Thank you. So all the new data that is coming through in the Lambda architecture, we need to split this data in 2 layers, basically. One, it's the batch layer. It's all that data that you want to see from 1 hour ago, from the last day, 1 day, or 1 month ago. So this is the kind of data that will be answering questions from some time ago. And the speed layer, it's more for the real-time data. So this is because I want to see all the messages that are passing through right now on Twitter, for example, or all the information that's coming right now from my operational systems. And if you want to know more about this architecture, I am letting here the link. And of course, our queries need to consolidate both views. So I need to collect the data that it's more a historical data and put together sometimes in the same dashboard or in the same view with the real-time data that I am receiving right away. And what else? This just you have in mind, this is a very, very nice news. We have Azure Synapse link. So basically, it's a link that I can connect directly to the operational systems and have some real-time data in a very fast way without impacting all the processing in the operational systems. For now, right now, we just have the support for Cosmos DB, but Microsoft is planning to bring more and support other kind of operational systems and database as Azure database. So keep your eyes on it, and we have very good news and features to work with this in a more simplest way. And that's okay. So thank you so much for joining this session. Here are my main contacts for one who wants to keep in touch with me and following all the events and other research I will be bringing. So basically, I am a specialist on data and AI, so feel free to reach me out after this session if you have any questions or need anything else. Thank you so much.